Let's try a little bit more, same concept. In example 2, you try. It says the table below shows the amount of cash in dollars left from $10 after a $2 lunch has been purchased 4 days in a row. So these are just random data points. We're just going to go ahead and graph them. So my X is lunch, so this is how many lunches were had. So I'm going to write down how it's labeled on my X-axis. My Y is cash left, so that's going to be my Y-axis in dollars. First thing I want to do is make the scatter plot. Scatter plot means I just plot my points. So 0, 10. Here I'm able to count by ones, so I'm going to do that. I'll just label it so that, because the last time we did it differently. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't have to, I could have counted by twos again, but since I have some numbers that are not all evened, it's going to be a little bit harder, like on my x-axis. So the first point is 0, 10. Let's use a funner color. 0, 10. Then I have 8, or 1, 8. So 1, and now there's $8 left. After the second lunch, there's only $6 left. After the third lunch, there's $4 left. After the fourth lunch, there's $2 left. I think we can see that each lunch, like it says, costs $2. And now this is modeling. After the fifth lunch, they're not going to have any more money. Okay? So we have our random points. Now we want to find the slope. So we're going to choose 2 points, any 2 points, because we know that the slope is the same between any 2 points. Even if you choose this, like big ones, it's going to simplify to be the same thing. So I'm just going to use the first two, 0, 10, and 1, 8, this and this. And I'm going to go ahead and find my slope, rise over run. So my rise has to do with the y values. I subtract 10 minus 8. My run has to do with the x values, 0 minus 1. I get negative 2. I'm sorry, not negative 2. I get positive 2. This was 0 minus 1. Over negative 1, which is negative 2. So my slope is negative 2. Now I find my y-intercept. My y-intercept is what goes with the 0 for x. So my y-intercept is 10. And if I check here, it's crossing the y-axis right at 10. Now I put them together to make an equation. Y equals mx plus b. My m is substituted in with the negative 2. My b is substituted in with 10. And there you have it. That equation models this situation about the lunches and your cash flow that's left. Which representation of a function more clearly shows whether or not the function is linear, a table of values or a graph? So this is our table of values, this is our graph. Which one of them shows more clearly that we have a linear function? Remembering, a linear function means that it's a straight line. I think, personally, a graph does. You can see that it follows a straight line. You see that the slope is the same each time. We're following the same pattern. Here, it's not as obvious. I mean, you can say, oh yeah, this is going up by 1, 1, 1, 1, down by 2, 2, 2, 2. It's linear, and that's definitely easily achieved. But for a quick glance, I think the first one, the graph, shows you a little bit more directly whether you have a linear function. But it's kind of a personal choice, seeing what you understand, what clicks a little better for you. Last thing from this lesson is that there's things called best fitting lines. So in real life, often people collect data and they're not necessarily going to be exactly precise. Every point is not going to follow a straight line like this one does, because you're decreasing by the same amount. But for example, the example here, it says the table shows the number of female physicians in the United States for the years 1992 to 1999. Well, there's no guarantee it's going to grow by the same amount. So this one's going to be a little bit different. And what we're going to do is we're going to make a best fitting line for this. So they want us to make a scatter plot of the data. Okay, so on my x-axis, I'm going to put years since 1992. 1992, and that's going to be our x value. So we're just going to count. It goes 0, 1, 2, 3, 4, 5, 6, 7. So I'm going to label those. We don't need to break them apart anymore. Now whenever we go to do our female physicians in thousands, we see that we're working from 110 all the way up to 177. And actually this is thousands. So this is like 110,000 up to 177,000. But we're just going to plot the values as they're given. our numbers are pretty big, so obviously we're not going to count by ones, we're not going to count by twos, tens, even 100, because if we count by hundreds, 100, 200, all of our stuff would fall right in that little range. So what I'm going to do is I'm going to put that break in the graph. I'm going to make this 100, and then 110, 120, 130, 140, 150, 160, 170, 180, 190, 200, and so on. Okay, I'm going to label this female physicians as best as I can write on the side. Okie dokes, in thousands. Oh, it's a little sloppy. Okay, this is our y-axis. So now we can go ahead and plot, and the more detailed, like we see this only increments by 10, the more accurate our graph's going to look. So 0, 110, right here. 1, 117, about there. 2, 125, right in the middle. 3, 140, that one's going to be right on the line. 4, 148, so close to the top. 5, 158, similar location. 6, 168, we start to see a little pattern there. And 7, 177, so a little less. Alright, if we look at our lines, they definitely look like they form some kind of straight line. Now if I were to actually connect them, they would not be straight. So I'm not going to do that. Like we said, these are just data points. But we see that this is a real life situation that does seem to model a linear regression, basically. It's linear, it's pretty straight whenever we look at all the data on a graph. It looks like it's making a linear function. So what we want to do is they want us to go ahead then, we made the scatter plot, draw a line that appears to best fit the data points. So notice here we're not going to connect them. Instead we're going to kind of draw a line that's basically going to be as close to each point as it can be. This is our starting point. It's kind of our ending point. So my line is going to go, and for what I'm doing here, it might be a little hard to keep it as accurate as possible, but there's a line of best fit. So this is my line of best fit. And what that means, it's the line that best fits the data. Notice here, it kind of goes right through this point, this point, this point, but this one's a little bit above it, and this one here is a little bit below it. So it's not going to hit every point exactly, as we have with our linear functions we've been graphing, but this is because it's real data. So some of these points are very close. It's a line that like goes as close to each of them as possible. And that would be our line of best fit. Now they want us to write an equation for this line of best fit. So to do an equation, we need two values, our m and our b. So two values to find the slope. They don't equal. We want to find our slope first. So I'm going to choose 2 points like we did above. I'm just going to choose right around here. It seemed to have the same, it increased by the same amount, and that seemed to follow a pattern. So I'm personally going to choose those two. Because our line follows different, not all of them are equal, you can choose whatever you want. I may actually choose my smallest and my largest points. 0, 110, and then 7, 177. So my slope is going to be rise, which is 110 minus 177. My run is going to be the x's, 0 minus 7. 110 minus 177 is negative 67, and 0 minus 7 is negative 7. So my slope is negative 67 over negative 7, which is positive 67 sevenths. That can't be simplified. We don't want to write it as a mixed number because we can't graph it then, so we can just leave it like that. My y-intercept goes with whatever point has a 0, so that's going to be 110. My x is 0. And my equation then is going to be the following. Y equals 67 over 7, x plus 110. Okay? Now, your slope may be a little bit different, so we'll talk a little bit more about this concept of what points to choose in class. Okay? But if you have something like this, you're set. Nice job, guys.